Recording in
is this idea of a relation or concept of a relation. Um, it's really a relationship, and we can define it very simply as a set of ordered pairs. And the first set of ordered pairs, when we're talking about ordered pairs, we're talking about X and Y. And the first set of unordered pairs, which would be the X component, is what we call the domain. And then the second component after the comma, the Y values, is the range. Okay. So just the idea of a range of a relation is just an equation that can generate a set of ordered pairs, and it just identifies some kind of a relationship. The ordered pairs, as we see here, like here's one ordered pair, second ordered pair, third ordered pair, fourth, and the fifth ordered pair. They got some decimals in there, so they look a little funky, but generally, just five ordered pairs they got there. So the domain is just all of the first terms. So you see that zero is going to come down here and go in our domain set. That's all that bracket thing means. Open up that bracket. It means we're going to name a set. So then we got a 10, we got a 20, we got a 30, and we got a 40. And the range is going to be all of the outputs, so the Y values, 9.1, 6.7, 10.7, 13.2, and 21.2. Okay. So that is finding the domain in the range for a set of ordered pairs that represent some type of relation. Now, within the concept of a relation, there's something that's a subset of that or a smaller group, and it's called a function. A function. Now, a function is a correspondence between the elements in the first set, called the domain, to the second set, and each one of those domain values maps or corresponds to exactly one element in the range. In other words, if we have a domain value repeated, then there's going to be an issue because it can't go to two different values. So what do I mean by that? Well, here's another example of one that's just identified by ordered pairs. You got 1, 3, 6, and 8. Those are all the domain values. And each one of those goes, let's see. So 1 goes to a 2, 3 goes to 4, 6 goes to 5, and 8 goes to 5 as well. Now, no two ordered pairs in the given relation have the same first coordinate and a different second coordinate. Let me put in something that would break that rule and show you. Because you'll notice here that the y, the y repeats, and that's fine. What we don't want to have repeat are the x values. And let me come up with something here. Let's say for this one, notice now that 1, 3, 6, and 6 repeats now. So 1, 3 are fine, but 6 repeats and it goes to two different values. So this is not a function because one domain value, 6, maps to two different y values. Okay? So this one would be a function, this would be not. So the best way I know to tell you when you're looking at ordered pairs is just to see if anything in the domain repeats. And if anything in the domain repeats, it should go to the same value. If not, like this, then it's not a function. All right, any questions?
So if there's the same number in the domain and it repeats itself, it's not a function, correct?
Okay, it's
Like
see how this one, it repeats in the first, but the second one goes to something different. But let's just say I replace this one with that. Theoretically, it's the same point and I'm just repeating it. So that doesn't break the rule.
right, because it's the same exact thing.
Yeah, so really technically it shouldn't be in there. So if it repeats like the 6, then that's going to be bad news because it can't go to two different ones. I'll show you a little bit more about it graphically in a minute, but this is just trying to do it with ordered pairs, which you're going to have a few that'll look like that, whether you're just looking at it from ordered pairs. But let's talk about it in terms of an equation. Now, if you write it as an equation, then the y, when you solve this equation for y, you're not going to be able, you're going to have an issue. Let me show you what I'm talking about. I'll just read this, but it may not make sense until you see this example. If an equation is solved for y and more than one value of y can be obtained from a given x, see, that's the same thing we talked about up there. If more than one y value can be attained for a given x, then the equation does not define y as a function of x. And this is a good example. This right here is what we call, it's a formula for a circle. And so, let me see something. Okay, they don't show you, so I'm gonna show you this graphically. All right, now to solve for y, all right, first of all, you're gonna subtract x squared, so it would be 1 minus x squared. And then to solve for y, you're taking the square root of both sides. And if you remember, the reason why when you take the square root of both sides, you got to throw in this plus or minus. So that's why it's not going to be just y is for a single value. That plus or minus is going to guarantee two different outcomes. If you look at the quadratic formula, it's got a plus or minus built into it. But that quadratic formula is solved for x and not for y. So it's not an issue there. Well, let me show you something on this. See if I can bring up this little graphing tool. All right, so here's the graph of that circle that they just gave us. So if you look at any value in here, and even for, let's just say 1, I say, well, let's back up. I tell you what, I'm going to make it 2, so that way we can look at 1 or 4. All right. So let's look at x is equal to 1, which is right here. X is equal to 1. You'll notice that if you come down here, you've got a value, and I'm not going to tell you what it is because it's not a rational value, so it's like square root of something. But anyway, there's one value here, and there's another one up here. So what it ends up being, it's the opposite values. In other words, it's the negative square root and the positive square root. And same thing happens for any value of x. So that's why this breaks the rule. And also, because of the fact that simply because there's this plus or minus in front of the x part once it's solved for y. So that's going to, by design, give you two different values that are going to map to that y. Because if we put in, and I'll just show you, let's go on the board here. That was it, right? Yeah. All right, so let's say x is equal to, let's just say, we'll just say 1/2, so that way it will, because if you don't, if you make it a whole number, you're gonna end up with a negative sign underneath there, and it'll be crazy. But anyway, so you have to be, and this is what we're going to get in a little bit later about domain values and all that. I mean, I hate to start with a fraction, but that's the only thing that's going to work here. So this is going to be plus or minus, and 1/2 squared is 1/4. So plus or minus square root of 3/4. And then I can simplify it as such. The denominator is a perfect square. All right, so that means that y is going to have two values. Y is going to equal to so see for every y, I'm sorry, for every x, you got two different y's now, and they're not the same. All right, so this one breaks the function rule. And that's why I wanted to show you visually. So what that amounts to, I think it was about 1/2 somewhere in here. So that's what these two values are right here. It was actually 1/2 right here. So that value right there would be 3 square roots of 2, and this is negative square root of 3 over 2. All right, any questions about that? Basically, if anything is done to the y, you got a problem. It's you can do anything to the x. It's just the y has got to be solvable for one value of x. And this little plus or minus is what throws it off. If we just wanted to have half the circle and just have square root of 1 minus x squared, then that would be fine. That would be just the top part up here. Or if we just wanted to have the bottom part, that would be fine. And we're going to learn about something a little bit later called the vertical line test that shows us how we can do it from the graph. All right, functional notation. This is written as f of x. Some students kind of tend to think it looks like an f times an x because of the parentheses, but f is a special I'm not going to call it a variable. Well, it's a special notation that means function. And we just read that as f of x, or f at the value of x. All right. So if we have f of x is equal to x squared minus 2x plus 7, then that defines our functional value. All right. Now, what's good about this is it allows us to be able to write in shorthand notation something like this. You could write evaluate or find f of -5, and that's a fancy way of saying substitute x equal to such and such into this equation. And it also, too, when we use the functional notation, then it's assuring us that we've got something that's a function that's going to give us exactly one output for every x. So this is f of x, and so f of -5 simply means, let's take -5, put it in, and then it's equal to -5 squared. All right, and remember, it's negative, but when it's squared, it becomes positive, all right? And if y'all got any questions, just ask and slow me down, all right? And then right here, -2 times x is -2 times the -5. Both two negatives gives us a positive 10. And then the 7 doesn't have any variable associated with it, so it just comes down. And so we add all those up, and f of -5 is equal to 42. Okay? Let me See, all right. Did Savannah come in? Savannah Alexi? I don't see her, so let's see. Okay, Britland was asking me questions, so I know she's in here. And Lanisha, Lanisha Cloud. I don't see her. Lauren. I don't see her. Let's see. And lastly, Kayla Jones out there. All right, so everything's accounted for. All right, any questions? I'll go back up here, and if you got any questions, feel free to ask. So this is where we were just talking about the functions as terms of ordered pairs. If x goes to two different values, it's not a function. And so the equation side of that, or trying to write it as a function, shows us what would happen. That if we solve this, which is actually a circle, for y, and essentially what we have to do if it's a function is replace y with f of x, but it won't work here because you got two different values. You got a plus or minus. So this plus or minus by default gives us two different values of x for each y. The functional notation, f of x, just as a shorthand notation to help us write out things without having to write too many words. And it also lets us know that something is a function. All right. Now, the graph of function is a graph of its ordered pairs. And remember, usually when you got a graph, you're going to have an infinite number of ordered pairs on it. So you don't ever necessarily see all the ordered pairs. Generally, when you graph things like equations and functions, you'll just take maybe 3 of them at the most, maybe 4, and put them on a graph and then draw a line or some kind of a sketch if it's not a line. And you're not looking at all of the ordered pairs, but all of those ordered pairs are on the graph. All right, here's an example of two different functions. These are what we call linear functions, like 2x minus, I'm sorry, f of x is equal to 2x, and g of x is equal to 2x minus 3. All right, now the old-fashioned, tried and true method for graphing an equation or a function is like this. You make the little table, and then you just start putting in points. In other words, -2 goes in there, times 2 gives -4. -1 times 2 gives us -2. 0 in there gives us 0. 1 times 2 gives us 2, and 2 times 2 gives us 4. And on the other side over here, the same thing's going to happen, except after we take the 2 times, we're going to subtract 3. So -4 minus 3 is -7, minus 2 minus 3 is -5, 0 minus 3 is -3, 2 minus 3 is -1, and 4 minus 3 is 1. So it's just very basic way to plot is to go ahead and do that. Now, we identify ourselves by another way to test for a function, and it's called the vertical line test. And I had mentioned about this one. If you look at any vertical line, and there's plenty of them on here, any one of these, like the -1, the 1, or the 0, they intersect this graph in two spots. So this breaks the function test in another way as well. All right, but let's look at, here's two different types of graphs. The one on the right, this is what we call a parabola. It's like x squared. And you'll notice that no matter where you draw the line on here, there's no way that you're going to intersect this in more than one spot. Vertical line. But on this one, which is actually x equal to y squared, which if we had seen that before, we would kind of know it's not a function because we can't solve it for y with just one value of x. But notice what the vertical line does. It's cutting this thing to point at the top and at the bottom in the same way that this was. Let's just say if I want to put in a vertical line. See, there's my vertical line. It cuts in two spots. Doesn't matter where the vertical line is at. Now, you can put it over here and not touch it, but the point is, if you can do it, is the issue. All right. And this is actually, if you're curious, the green line, this dot right here and that dot right there are those two values, that square root of 3 over 2, negative and positive. That's those things right there. There's the two of them. If we just looked at 1/2 of this thing, then there's no problem. But if we're looking at it to where vertically it's got some kind of a shape that covers it twice, then yes, it's going to break the function rule like this one. All right, any questions? All right, so let's just say we want to look at a graph. Doesn't matter what the graph is. And we want to find some kind of values. This could be important in some type of a scenario where you're looking at an article or you're reading a textbook and you see a chart, and they'll maybe ask you about certain values, or they'll tell you that certain values are present and tell you what they are, but you would have to go through and look in order to make sure. Well, let's look what we got here. All right, it says use the graph to find f of 5. Now remember, what's going in is the x value. All right. So here's x is equal to 5 along that way. See, they even label it as x there. So if we go over to 5 and then we go up until we hit the line, we'll see that it's right on this 400 line. So we can say that f of 5 is equal to 400. All right, f of 5 is equal to 400. In other words, the horizontal value is x5 and the vertical value is 400. Now they're asking us sort of the opposite question. They're asking us what value of f of x is 100. In other words, what output of 100, what does that map to? And 100 will be smack halfway in between here and the axis there. So if we go over there, and we'll see that it lines up at or it crosses the graph at 9. So f of 9 is equal to 100. All right, let me come up with something. Y'all, if y'all got any questions, let me know. I'm gonna look for something kind of here to help me with something for y'all to view visually. Hmm. Hmm. All right, let me just down. So we talked a little bit about this type of function last time, or this type of equation. Absolute value. All right, what do you think about this question here? Does x equal to the square root of y represent a function? There's several different ways to handle it. We've looked at 3 different ways to tell. There's solving for y. There's also looking at ordered pairs, and we can also graph it. All right, let's do this kind of thing. All right, let's just say we put in 0 for y. Then that would give us 0 for x. All right, let's just say we put in 1 for y. What would that give us for x? We can even write it up here if we need to. So absolute value of 1 is equal to 1. How about if we tried -1 here for y? What's going to happen?
1.
Yeah, it's also going to give us a 1. So what have we established so far by looking at that little thing? And if you need to write them like this, then it's all right.
It represents a function. Is it true?
Well, let's try to do it this way, just so you can make sure. So this is the way we looked at it. Okay, we've got the same X value repeated. And what does it go to? Two different Y's, right? So that should be a hint. But if not, let's go ahead and look at the graph. Well, how did they do absolute value in here? Hold on a second. Let's see if I can figure this out for you. It's got two X's that go to something different. So that should be enough. But if we're not sure, then what we're going to do is graph it to see. I may have to do it by hand, but I was trying to get this to do it. Hmm. Why? Oh, that's what I had X in there. I mean, so there's the graph of that. All right. See, what it amounts to is when you do funny things to Y, that's when you start running into problems. If we'd have had X is equal to, see, then it's not a problem. But this one, when we do funny things to Y, see, we already breaking the rule. And we also broke the rule here because we've got those ordered pair or the ordered pair one repeat to do different values. And we'd had any number of them do that. It would one wouldn't be the only one. Same thing would have had to happen with X is equal to 2. So if we put in 2 and we put in -2, same thing's going to happen. Both of them are going to give us X equal to 2. So in other words, we would also have these thrown in there. 2 and -2 and 2 and +2. So my short way of saying this is if you actually have access to the function, then because something is being done to the Y, that's not good. There's no way that we can write that by solving for Y and not have two different X values pop out of it. Okay? All right, so sometimes we can look at a graph and determine its domain and range in that way. So to do that, what you want to do is just kind of focus in on the, to find the domain, you're strictly looking at X. In other words, you're ignoring the Y-axis for the time being, and you're just looking at the endpoint here and there and what they come to on X. So this one's pretty easy because it starts at -2 and then it goes over to X is equal to 1. So the domain is everything between -2 and 1, including those endpoints. Now, we'll see in the next spot, in the next one, that if there's a hole, then it means to not include that. But anyway, now looking on the Y. So if it might help if you cocked your head like and looked at it sort of like sideways like that, because you're not paying attention to the X anymore. You're looking at the Y axis. So on the Y axis, this one comes down to 0. See, it never drops below X is equal to 0. I'm sorry, Y is equal to 0. See, this is Y is equal to 0. This is Y is equal to -1. Y is equal to -2. There's Y is equal to 1. So on the Y axis, it comes no lower than 0. And then it goes up and it stops here. And then we can go across and see that that's Y is equal to 3. So this right here is a fancy way of saying that Y is in between 0 and 3 inclusive. And then this is the interval notation function for it, that it starts at 0, bracket means it includes 0, comma, up to 3, including 3. All right, questions? All right, so this one's slightly different. This little circle right there means that's a whole, meaning that that's X is equal to -2. So that line gets very close to -2, but never gets there. In other words, -1.9999999999999, and you can add as many nines as you want, and it gets up to that point, but it never gets to -2. So on the x-axis, what we're going to do is we're going to use the value of -2, but we don't put an equal sign underneath there. It's just the less than. And then going up on the other end, it goes up to 1. That one has a filled in circle. And then it includes that 1. So -2 to 1, not including the -2. All right. Okay, now on the Y, and again, if it helps, you can kind of cock your head one way. So in order for it to be the same orientation, cock to the left like that. So that way, the downside is on your left, like a normal number line would be. And it comes down to -1. See, that's a -1 there on the Y. Going up to -2, but it does not include -2, so there's no equal sign. So the interval notation for both is -2 with a parentheses, meaning it does not include -2, and up to 1, including 1. And this one is, they're just the opposite as far as the whether they touch or not. But this one right here starts down at -1 and it goes up to 2, but never gets there. Questions about that?
Yes, I have a question.
Go ahead.
So the closed bracket is the -1, is because it's on the -1. I mean, the open bracket is the -1. Does it matter, or is it like that make a difference, right?
You see this right here, where I got the blue dot right there?
Mm-hmm.
See where I'm at?
It's closed, right?
Yeah, see, it's closed. So that means it includes that point. All right. That point right there is 1, -1. All right. This point over here is -2, 2. Right. That point, this point, it does not touch. This point, it does touch. So the way that we write that in this simple interval notation is to do it, on the vertical axis, I'm sorry, on the horizontal axis for x, we start at -2, but it does not include that -2. See? Does not include the -2. So that's why it's got the parentheses. But going on this side, as we go across, we stop at where the dot is at, the last dot. That's 1. X is equal to 1. But since it's a filled in circle, that means it includes 1. So that's why we have the bracket there.
Okay.
Okay?
Uh-huh.
If you look at it on the vertical for y, here's the lowest point on the y-axis, which is, again, that's a 1, -1. But we're only looking at, for the y, we're only looking at, the y-axis. So that's -1. And since it's filled in, it includes -1. So that's why the bracket is there. And then go on up. And that's the end. That's 2. But it does not include 2. So that's why there's a parentheses. Usually back in most people's junior high and high school days, they use the circle and they filled in the circle, the open circle and the filled in circle to mean what you see in here with the interval notation. Like the filled in circle means bracket. The open circle means parentheses. Okay. All right, so another thing, or the last thing we're going to look at is being able to tell x and y intercepts from a graph. It's very simple because x-intercepts are where the graph crosses the x-axis. The y-intercept is where it crosses the y-axis. Now, you can have more than one x-intercept, but only one y-intercept for it to be a function. So let me show you. All right. So this is what we call a cubic. They don't tell us what it is. I think eventually we might look at a few of these functions later. But you got a kind of a parabola thing there, and you got another one coming back up. So this thing crosses at x is equal to -3, x is equal to -1, and x is equal to 2. All right. Now, on the y-axis, there's only one, and this is the way it should work for a function. Only one y-axis. Because you realize back up here, when we were looking at this one, well, that's not a good example. Let me draw one out for you. All right. So here's one. As we established before, this is not a function. Let me try to do something else. Make it shorter. There we go. See, it crosses at 2 points because the y-axis, since it's a vertical line, if it intercepts in more than 2 spots, then that breaks that vertical line test. Okay? So that's why we don't want to have more than one y-intercept, because that's going to establish that it's not a function. All right. Any questions? I'm probably going a little bit faster than I need to, but I kind of just playing it by ear. So if you got any questions about anything getting set up, because let me just go in and see how many people are signed up? Because we got how many? Hold on a second. I got this is like allergies that are bugging me. Just a second. All right. So now let's see, we got 1, 2, 3, 4, 5, 6, 7. That's what I hear. I'm in a class right now. And 12, 13, 14, 15, 16, 17, 18, 19, 20. So it looks like we got everybody signed up. Because that's how many people's in the class, I think. All right, so let me just make sure. I think that's what we got. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20. Well, there's a couple of people extra, it looks like. So I got 20 people on the My Math Lab. And it looks like there's a couple here, more than 20 in the class. So if you got any questions about that, about how to do that, I'm going to let us out a few minutes early here. But the other thing I wanted to say, make sure you got to have that My Math Lab stuff done. All right. All right. And then, I mean, you got to be registered in My Math Lab because this is what you got to do to take your first test. All right. You got to go over here. You should be doing your homework. If you do all or do quizzes and tests, make sure you do this browser check. All right. You got to have this in order to do your tests. Okay. Make sure you do that. You got to download this and install it either on a PC or a Mac. It does not work on Chromebook as of yet. And then keep up with your work. I'm going to have a practice test in there already. You won't see it until next week. And the other thing is, under assignments, and I have to show you as a student, it looks different. Under assignments, make sure you do that, upload your photo ID, okay?
I have a question while we're on like the test stuff.
Okay.
So Tuesday for our test, do we have to come on here at the same time as we normally do?
No, I want to have it open up, and what I'll do is on Tuesday, I'll just have an open day for answering any questions,
Uh-huh.
and then it'll be open, and it'll be open until
Like midnight?
the next night. The next night. In other words, midnight. Well, 11:59. 20 whatever it is. I think it's this September 1st. So that then when we come back on that Thursday, I think it's the 2nd, we'll start with new stuff.
Okay, so we're done with the material for test 1, correct?
Pretty much. I'm gonna go back, try to find something else to keep us busy on Thursday, and then get into a little bit of review. And then also next Tuesday will be an open day to go through any of this material, because I like to get an idea of what people have questions about, so I want you to bring your questions next time, because I don't want to feel like, I'm not doing anything. So if feel like I'm not doing anything, I got to go on to new stuff, and I'd rather not do that if I don't have to. Okay.
And as I go, I write down my questions. So like before the test, maybe Thursday, I'll have
That would
my
be great.
questions that I have. And also for the test, do we have to, every quiz and every test, we have to go on My Math Lab and use the lockdown browser, correct?
Not the quizzes, but
Not the
tests
quizzes,
and
the
exams.
test.
I've just coded this one as a quiz.
Okay.
So for example, you won't see this until next week, but I've got them timed. See, test 1 is right here. It'll open on the 30th, and then on
So
the
the test, So the test will be open on Tuesday the 31st. That's the first day, and then until the next day, which is the first.
Yeah, like the end of the day on Monday. Like if we look at it on the calendar. So it'll
Wait, I think it's right here.
yeah.
Hold up.
See, it'll be open up on
Yeah,
Tuesday, and then it'll
the
close
31st. Okay.
and see, but this one is a practice test. You won't need to have the lockdown for that, but you'll have to have it for this. And this one, I'm going to take it out. I was just kinda
So
like doing
every
this.
test we use the lockdown, we don't have to for quizzes, correct?
Right, exactly.
do.
If it's coded as yellow, you know that yellow, see that the respondus is the exception because I just wanted to give you a trial run on that respondus before you.
And
jump
one
in.
more thing, are our tests like multiple choice, or we have to print a sheet and send that back to you, or what is?
Well, yeah, it'd be optimal. I may not enforce it until the exam, but keep all your stuff and then scan it or take a picture of it and send it up. You can upload that in Canvas. I'll make a place for it. I don't think they have anything like that in my math lab.
Okay.
So it's all assignments due. I'm sorry to cut y'all. Is all assignments due like for that particular section?
Well, I just left the ways that she gave.
I didn't see.
Because I didn't see any due dates. What is the due date she's got? Yeah, see, she doesn't have any due dates on them. I could go through and change them. I just thinking about leaving out the videos. Does anybody use those videos? I mean, because I don't, this is just making them as a grade, and I don't see the point of that myself. You can always go in the multimedia section and view the videos. But yeah, she doesn't have due dates on it. So, I mean, I would optimally say is this. So let me just write this on here. Let me write this on here. Doing homework within 2 days of coverage in class. I said she didn't have any due dates on it. But I don't think that's good practice because they're still going to be open, and I can't let people still be working in there after the final exam. Once the final exam is done, so I'm gonna have to change them. But I'm just now noticing that there wasn't any. So that's just what I recommend doing right there. I'm not going to close them. If anything, what I'll probably do is like close them right at the time of the test. I think that's what I'm going to do. But you can still go back in and work on them. I'll just give them a due date and then I'll keep them open afterwards if you want to go in and change, work on them afterwards. All right, so anything else? All right, well, I'll see you Thursday. Bring any questions you got, because like I said, as we covered more than I wanted to today, and bring anything you got back on Thursday. If you got any questions, then I'll stay here for a few minutes. Yeah, well, that's what I hear, but I don't understand where the office is at. Somebody told me it was on the second floor. Somebody said it was all the math offices were on the first floor. So I don't know. Okay. Thanks, Jennifer. See you.
I wanted to make sure, because I came in a little late.
Savannah, yeah, I got you.
Yeah, okay. I was just making sure that it was
Yeah, I usually do it at the beginning and then I look again.
okay. Hey,
Yeah,
thanks.
okay. All right, anybody out there still got a question or we going done? All right, well, I'm gonna close it down. Email me if you got any questions.